Hello developers, let's start developing. My name is Veko and we're gonna be taking on the 22nd task of the 2021 Advent of Code. I've taken a look at the task and I think I have a feeling for what it is. So we have some kind of a 3D matrix, 3D grid, which is our reactor, submarine reactor, and we need to reboot it. Rebooting it includes setting all the cubes in the matrix. They're called cubes, but they're basically points. They're basically pixels or vexels, or how do you call 3D pixels? So we have those, and we have these reboot steps. So we can do a simple, so these things that turns all the pixels that have coordinates 10 to 12, 10 to 12, 10 to 12, so that those are 27 pixels. And that's one trick that people usually don't really understand, I mean in their gut, that when you have cubes everything goes much faster. So this looks like a tiny cube. It's 3 this way, 3 this way, 3 this way. And everybody feels, well, that's like a dozen points at most. No, it's 27. And if you have 5 by 5 by 5, you have 125. And if you have a 10 by 10 by 10, that's 1,000. And in this case, we have a 101 by 101 cube by 101. So we have some kind of a set of cubes that we can just go through and turn everything on or everything off and run through it. So for the first part we're turning this on, for the second command we're turning this on, and you can see that there is some overlap, so of course we're not turning the ones that are already on. I mean we can, but they're gonna stay on. And then we're turning some off, and then we're turning a single cube on. So that is the thing that we need to do. And after that we have 39 cubes. This is a thing for the part 1 that says that we will only look at cubes in the positions of -40 to -50 to +50. So that's a range of 101. So we have 101 times 101 times 101. So it's about a million points. And a million is not such a huge number. We can handle a million points. So that's how we're gonna do. But looking on the input, we have this, and then we have this. And we have this, so to say, foreshadowing. The last two steps are fully outside the initialization procedure area, all other steps are fully within it after executing these steps, and so on and so forth. So for now we are supposed to ignore this part. And looking at the puzzle input, well, without that part we just have this. And with that part we have a lot more. So I have a distinct feeling that for the second part we will need to arrange this. And to be honest, let's just take this for example. So we have, how large a cube will we need to model this? So we have 83 to 77,000, that's 6,000 time. And this is something like 23,000, and this is some like 10,000 points. That's gonna be this many points. So these are millions, these are billions, so we're gonna have a trillion points. And this is just part of it. So if we have something that's 100 points wide by 100 point wide by 100 points wide, which is not a lot if we're gonna be this many pixels, and that's a lot of pixels to put in memory. Millions, billions, trillions, I guess quadrillions. So I don't think that's enough memory. So this is megabytes, gigabytes, terabytes. So we're gonna need a 1 petabyte of memory to basically store all of this. Technically doable if we have a lot of hardware, but why? There is usually a much better way to analyze it, so we can just calculate it instead of counting it, like we did yesterday with all the universes. We counted some, but we calculated and extrapolated the whole thing. So first of all, of course, we're gonna need to have an input. And if when the input is this kind of things that we are just having some text, well, I'm gonna do a regex. So we have on or off, the command that we want to do, then a space, then x equals, and then we have the numbers that we want to get. And this is something that can have a minus and then has some numbers. And this is some that also can have a minus and then has some numbers. Seems like we're getting there. So the rest of it will just be this 2 times over, but this times it's not x, it's y, and this time it's not x, it's z, and then it ends. Let's see if we get everything matched up. We don't have some weird case. No, we don't. And looking at that, let's take a look at the actual test input, because we're gonna be working on that first, because we know the answer. Yeah, looks okay. Minus 20, 26, minus 36, 17, 47, 7. Okay, so let's use this to actually process the input. We're gonna need to read all the lines. We're gonna need a regex. Yeah, people have been calling it, whether it's called regex or regex. No, a regex is correct. If you're calling it regex, you're wrong. So we're gonna get I'm gonna call this a command. Is it a command? Steps. It's a command. So each command has a direction, action, which can be on or off, and it has an X, which has a from, which is a number, and a to, that's a number, and it has a Y, and it has a Z. And we're actually gonna use a command array as our input. So we need to map the lines. For each line, we need to return a command. Oh no, we're gonna need to do some proper coding here. Match arix. Let's see what the suggestion is. Yeah, this is okay. We need to stop the processing because, well, we have an error in our regex most likely. Otherwise, we have 7 things that we can take from, and those are the 7 things that we need to do. Yeah, so I guess that, yeah, this is the action, and this is that, and this is that, and that is that. Yep, and we're just gonna cast it as a command, and as usual it guesses everything except my preference to explicitly add a 10 to %. I've been burned before, and that's why I do this kind of religiously. And we're gonna return a result. Let's run this and see if we're getting what we want to get. Oh, it actually set an invalid line. Invalid line, empty line. Do we have... Yeah. So, of course, that part didn't work because we didn't put anything inside of it. Let's see on this example. On, off, on. Yeah, that's the goal. So, now we can do something like that. We can have the reactor core. It's not a grid, it's a reactor. And that's gonna be, so what I will do, since this is minus 50, minus 50, minus 50, I don't like working with negative indices, and I don't think there's anybody who actually likes that. So what I will do is I will offset all calculations by 50. Low equals minus 50. So now all of the things, instead of going in the minus 50 to 50 range, it will go in the 0 to 100 range. Because basically we don't really care about that. We don't care about the values, we just care about the range. And thinking about things in minus 50 to 50 range with negative indices and everything, to be honest, kinda hurts my brain. So in order to do that, we're gonna need to shift the input as well. Yeah, take everything. Actually, don't take everything because that's just the action. Let's be explicit. And it actually gets this, only we don't want to add it, we want to subtract it. Because we want to subtract minus 50 and then we will get something else. Another one of these. So like that. Yep. Let's see the translated values. They should all be positive. Very positive actually. Yeah, and it looks like we're on. So the important part is that we keep the difference, so to say. So this is one difference, two difference, two difference, two difference. Yeah. As long as all the relative positions are okay, we basically have no problem. So once we translated that, we just need to process them. And we're gonna have a new array of actually 101 member. and we're gonna fill it with zeros, and then we're gonna map it to a new array that we're gonna fill it with zeros, which we will map it to the same thing. I actually prefer to have this here. Yeah, let's have it like this so dimensions are visible better, and then yeah, it's not any, it's a number. We're definitely filling it with zeros. Yeah, it's a tri-dimensional grid array matrix, how we want to call it, of pixels, and it's filled with zeros. And now we can just say for of command of translated. We just need to execute that command, and how we're gonna execute it, well, that was actually a pretty good suggestion, because I really don't want to write nested for loops. So command X, from command X to up to and including, yes, up to and including, up to and including. If the action is on, then the reactor value is 1, otherwise the reactor value is 0. And then we just need to say, well, let's reduce this whole thing and count it. The ones that are on, something like this. Do I have a selector? Yeah, I do. So maybe I have a simpler way to write this. We're gonna zooming it, and z is a number, and we're selecting it the number, so we don't actually need this. And yeah, we have 3 sums. So for each, so basically each index is actually a matrix that is, so to say, on the z-axis. Yeah. So for each matrix, take, this is a matrix, sum its rows, and this is a row single column, and that we can actually sum. Let's see this total brute force approach, whether it will work. And to be honest, this is gonna be a two-parter because of time constraints and everything. And you can see that it took us 2 seconds to actually do this. And more or less, the most of the time will be creating and processing and everything, so it's gonna be about this much. Doesn't matter what our input is. It's actually gonna do, yeah, it will depend on the sizes of this, because if it's different if you want to turn on 7 or we want to turn a million, but still we need to turn some more. So we have 39 cubes. If we do this, and actually we can just, we need to skip the large ones. We we can just say if command, let's filter them out at front. So when we're mapping them, we should filter command. So for each command, if command x dot from is, so this becomes easy, because if we have a negative number, filter this out. If we have a negative number on the y and the z, and I'm just gonna assume that they are correct, so we don't have something that goes from smaller to larger, so we don't have a case like from 12 to 10. If we have that case, I'm gonna cry about it later. So if any of these is bigger than that, actually let's hard code this. So if it's less than 0, return false, or if the 2's are above. No, no, no. Here. And later on I will see if I made a mistake and some of these are actually taking the origin into account. Let's do a visual check actually, because in this case we have two negative numbers and this doesn't take the origin into account, we're good. This has two positive numbers, doesn't take the origin into account. I want to avoid a situation when we have something like minus 10,000 to plus 10,000, minus plus to plus, minus to plus, which actually will cover all the area 100 by 150 by 50 area that we are taking care of. So this is out, this is out, this is out. I'm just looking at the excess and I don't think, actually yet let's use a regex for this, but I will just use it here. So we have for the x's we have two cases. So find me somewhere that has an x that has a minus and the other one doesn't have a minus. Yeah, these are okay. Why does this match? Oh, I have an error in my... This is supposed to be a literal dot. Fortunately, we have nicely behaved input, but it would have matched if this was basically anything. But on the other hand, if it matches, it matches. So we have this case, and I will remove everything that doesn't match because those are not interesting. We want to filter them out, and we are filtering them out. Wow, there are a lot of these. Okay. And let's take a break here. So let's continue with the fun exercise of removing rows from a list. The things I would do to avoid writing code. On the other hand, I could have written a script to do this for me, but I already did the bulk of the work. And that's the worst case, when you know that you should have done a script, but you didn't. So these are... oh no. We should have looked at the other way around. So from this, we might get more matches. We actually want to do this. We don't need to capture anything right now actually. So this is okay, but we want to do this, or this when we have this and this. And why do we match everything? Because we have it like this. So these are the ones that are passing the Y origin. And none of them, as I see it, are passing the Z origin. So we can have a situation, so I will just assume that none of them are passing the full origin. So they're basically passing the origin on all three axes. So if one of these is above the high number, and it needs to be above because equal to the high number is okay, because we are mapping this up to the high plus 1, which means that we unwittingly did this. So this is the highest index possible, 100, so that means that we have 101 elements. Let's run our test once more. Yeah, it is a bit faster because we don't have as many elements. Let's take the big example and try to run it. We'll know if we get to run, if we don't exclude the elements that we need, because this will take forever, but I guess that we either excluded too much or didn't exclude enough, because this says that everything is 0, and it should definitely not do that. So let's debug it. So how many commands we have in the input? We have 22, and this is 22. And how many commands we have in the translated? Well, 0. That's no good. Okay, I am a bit of an idiot, because we are returning all the false cases, but we're not returning a true case, which means that this will definitely filter out everything. By default, JavaScript methods will return an undefined value, and an undefined value is falsy, and that will filter out everything whether that's needed or not. So for translated now has 20 because it excluded only the last two that we actually wanted excluded. So we have 500,000 or so of cubes around. And if we use our huge example, which is our actual input, we are getting that we have mapped, well, about 500,000. Let's see if that is maybe the correct answer. Yeah, that's the right one. And now I'm dreading to click back because I think that part 2 will say, well, actually take care of this. So that was just the initialization procedure. Then that is complete and we can actually reboot the reactor and run all of them. That's just it. Yep. And this is gonna require some different thinking, or otherwise we might need to basically use the Googleplex to calculate that. But we'll talk about that for at the second part of this video, which should be available right over there somewhere. Yeah, right over there somewhere.